Good morning, my YouTube viewers. Crystal here. What I wanted to do is I wanted to give you the solution to the Analytics Vidhaya Healthcare 2 competition question. I think that I had previously made a video on this. I definitely had worked on the competition question a month or so ago. I think it was in August, or let me see, when was the last thing that I did? Well, September, so it was a month ago that I worked on it. But I've done some more work on it because I learned some more things. And since I had worked on the Healthcare 1 video, I decided to go ahead and pick up the Healthcare 2 video and do some more work on it. And I did improve the score. The original score that I did back in September was, 34 almost, and the score now is 38. So I improved it by 4 degree points. I could have tried to improve it some more by fine-tuning my parameters some more, but it took me over an hour, maybe 2 hours, to for the system to churn through every time, and I just don't have the time to sit and let the system churn through like 1 or 2 hours every time I want to make a change. So I just decided to leave it as it is, but it could do with some more parameter tuning to improve the score. You never know. But this score that I got was 38, and the highest score that I got, the highest score on this competition question was almost 44, close to 44. And so, I know I'm not the best programmer. I'm very logical and methodical, but I'm not the best programmer. So I don't really think that I would have gotten it above the highest score, but I could try to do some more parameter tuning, and I could try to do some feature engineering to see if I could get this score improved more than it was. But because it takes such a long time to do it, to load the program, and for the XGB Classifier model to work, I thought, well, I'll just leave it like it is for the time being, and just so I can make this video and show you my solution. So what we're going to do now is we're going to go over the solution to Analytics Vidhaya Healthcare 2 competition question. It's on GitHub, so you can go onto GitHub and follow along with me if you like. The first thing that we'll do is we'll go through the problem statement. The problem statement is, recent COVID-19 pandemic has raised alarms over one of the most overlooked areas to focus, healthcare management. While healthcare management has various use cases for using data science, patient length of stay is one critical parameter to observe and predict if one wants to improve the efficiency of the healthcare management in a hospital. This parameter helps hospitals to identify patients with high LOS, that's length of stay risk, at the time of admission. Once identified, patients with high length of stay risk can have their treatment plan optimized to minimize length of stay and lower the chance of staff visitor infection. Also, prior knowledge of length of stay can aid in logistics such as room and bed allocation planning. Suppose you have been hired as data scientist at HealthMan, a not-for-profit organization dedicated to manage the functioning of hospitals in a professional and optimal manner. The task is to accurately predict the length of stay for each patient on case-by-case basis, so the hospitals can use the information for optimal resource allocation and better functioning. The length of stay is divided into 11 different classes, ranging from 0 to 10 days to more than 100 days. So that's your problem statement. So you have to decide how long every person is going to stay. So the first thing I did was I imported the modules that I thought I would need. And then I loaded the data sets. The data sets were so large that I had to actually load the data sets on my Google Drive. So at some point, the data sets will probably be removed as I get more and more files on my Google Drive and have to delete files. The next thing I did was I had to change the column names, and the reason why is because some of the column names had spaces in them, and it's hard to work with a column name if it's got spaces in them. So I took the column names that had spaces in them, and then I put little underscores where the spaces were to make it easier to work with that column name. So you can see the train file here. See, it's a big file. You have case ID, hospital code, hospital type code, city code, hospital region code, available extra rooms in hospital, department, ward type, ward facility code, bed grade, patient ID, city code patient, type of admission, severity of illness, visitors with patient, age, admission, deposit, stay. So stay is your target variable. It's your dependent variable, and all of the other variables are independent variables. So test score is the same format as train score, except it doesn't have a stay column. And here's your sample sub. This is what Analytics VidHaya wants to see when you submit the sample. They want to see a case ID and a stay column. So this is train data. This is just a description of what all of the columns mean. So now what we do is we check the train and test file for any null values in the data frames, and you can see we have some null values in the data frames. So what I had to do is I had to impute those values. So what I did was I replaced the two columns that had missing values with the most commonly used values. Okay. I had to check the two data frames for any null values, and there were no null values. I did a graphical representation so you can see how the different independent variables correlate to the dependent variable, which was length of stay. Then what I did was I pre-processed the data. The first thing I did was I encoded the target variable. If you look on the sklearn documentation, the sklearn documentation says that label encoding is only supposed to be for the target, and which is what I did. And I tried to follow the sklearn documentation and use the label encoding only for the target, but it didn't really work out that way. Now, what's important is in the beginning of this program, we are label encoding the target, but at the end of the program, we have to reverse what we have done. And since we're going to be doing a lot of label encoding, and the target is going to be reversed, we assigned a different variable just to label encode the target than we did the other variables. And if you don't do that, when you get to the end of the program and you try to reverse what you have done, then it won't work because you will have information from other variables that have been encoded in the memory. So that's why you have to assign a separate variable for this. So now you can see what's in the stay column. And as we've done a group by in the stay column, so you can see how many counts you had of each variable, because we had 11 categories in the stay column that we had to choose from. And in the stay column, they had 0 were 0, but we'll see how that goes. So we did a graphical representation of the stay column, and you can see that we have an imbalance of categories. 2 seem to be the highest length of stay, and then 1 and 0 and 3. But you did have an imbalance of categories, and so we were going to have to do some work on that as well. Now what I have done is I have gone through and I have labeled and coded all of the different object columns to convert them to numerical values. And the reason why is because the computer wants to see numerical values. The computer does not want to see words. And so anytime you have a word in a computer program, it's going to have to be converted to a numerical value so the computer can see it. And then what I did was I converted floats to integers. And the reason for that is I just want to chop off the decimal part of the integer. I think on the city code patient, that was already an integer format. It just somehow or other it got put into a float. And the bed grade, I just wanted everything to be an integer, even if it was the last bit of it was chopped off. But I think that this city code patient, I think that was already an integer as well. But for some reason, it just got put into the float, which that's not what I wanted. So now you can see the train file, and you can see everything is an integer, which is what I want. I want everything as an integer. Now we define our X, Y, and X test. Your Y is train stay values. Your X is train drop stay case ID, patient ID. Axis equals 1. If you don't put axis equals 1, it won't work. X test is test drop, case ID, and patient ID. Because the case ID and the patient ID are not needed, they do not add any value to the computer, to the algorithm. So that's why you drop those columns. So now what we're going to do is we're going to use smoke. That's what that is that gives you synthetic information to balance out the categorical imbalance. And you see we got lots of warnings in that as well. So now what we've done is we've split our training and testing set into X train, X val, Y train, Y val. We use X and Y, random state equals 1, test size equals 0.1, and stratify equals yes because there was an imbalance in the categories. And then we tested the shape as well to make sure that the shape was okay. Now what we've done is we've defined our model. I decided to use XGB Classifier. I tried to use his gradient boosting classifier, but it took so long. All of them took so long. They all took an hour or more to go through one cycle. And I thought, oh, I just don't have time to wait for this. I was exhausted last night. And so whenever I got my score of 38%, I thought, well, I'm going to settle with that. The highest score was close to 44, so I thought, well, I'm going to settle with that. You know, I could have tried to get my score higher by adjusting the parameters some more, hyper-tuning the parameters, but the thing is that it was just taking so long. I thought I'll just stick with this because I want to make this video. So we printed our accuracy, which was close to 58%. And then what we did was we predicted on XVal, and that accuracy was close to 53%. We created a data frame to show the predicted values versus the actual values. And then we created a confusion matrix. And then what we did was we created a classification report just to tell you the accuracy, the precision, recall, F1 score, and support. So now what we did was we predicted on X test, and then you had to say X test values, otherwise it wouldn't work. And you can look at the sample sub. It was case ID and stay. This was the format that Analytics VidHire wants to see when they you submit it. When we got our answer from predictions, what we had to do is we had to go through and reverse what we had done with so that's why you got predictions equals LES dot inverse transform predictions. And then so you can see the rate of the answer. We put the final results in a data frame of case ID and stay, and then we uploaded it onto the system, which I had used Google Colab to write this program. And so we downloaded the submission file and we uploaded it to Analytics VidHire, and I got my answer of almost 44%, which I know isn't answer of almost 38%, which I know isn't very high, but the highest answer was 44%. So I thought, well, that's pretty good. And I'll stop there because I don't have a lot of time. And, we could have tried to tune the hyperparameters some more. Tune the parameters some more, but it's just because it took so long to do it. I just thought I'll stick with what I've got. And I could have tried to use the HIS gradient boosting classifier, but it just churned away and didn't know when it was going to finish. And then I could have tried to use MLPC, and again, that just churned away. So I settled with XGB Classifier, and you've got your answer here. So this concludes our presentation on the solution to the healthcare 2 question presented by Analytics VidHire. And if you like my program, please like, subscribe, and share. If you like the work I do and you want to leave a donation, I've got my email address for donations down below. The reason why is because I am not monetized because I don't have enough subscribers. So the only way I can make any money on this channel is to ask for donations. But as soon as I get enough subscribers and I'm able to monetize, then I won't be asking for donations. So thank you very much for watching this video, and I look forward to making the next video for you.